And all we ask is that during the course of the meeting, someone occasionally captures all the text, because there are experiences in our not so distant past where the whole thing has disappeared. But it's really easy. We're going to stick to this agenda. It's all right here. And for example, you just stick your cursor there and press return, and then you're typing notes. Isn't that wonderful? So easy to do. All right. I'm going to get off of that for the moment. And again, you get to that from the Bmwg tools page under the minutes link.
So we have one note taker, but he is a presenter. Could we get a second note taker to help shore up the notes? You'd be surprised how often that's beneficial.
And there's major kudos for that.
There are major kudos, especially to the gentleman in the red t-shirt at the very back of the room. Hi.
I would love to, but I'm going to have to leave early, which is why I'm not on.
Mike, you are next on my list. Good try, though. But yeah, would you mind backing up and taking a second set of notes for us? Thank you. All righty.
Okay.
Fantastic.
So the rest of you can stop hiding now. Very good. All right. So just to let you know, we're the working group chairs have a new facility at this meeting, which is the Chromebook, which is sitting in front of us. And the Chromebook means that Sarah and I don't have to dedicate our own laptops to note-taking and slide sharing and things of that nature that generally take up our own facilities to ask good questions and refer to our own notes. And so we've got a little, it's 13:31 now, we might as well get going. So I've already pressed the magic button here that scores a full screen display. And then this button, which gets us right to the truly useful full screen display. And this apparently works with slides that are 16 by 9 or 4 by 3. And you can advance them with this thing right here, the clicker.
Oof.
So, and that works apparently. So welcome to Bmwg. I'm Al Morton. This is Sarah Banks. And we're the co-chairs, and we're going to entertain you as much as we possibly can today with all the things that we've prepared to hand off the mic to our friends and neighbors who have worked so hard to prepare slides, drafts, and done research at home to make this an interesting meeting. Our AD advisor is right here in front, Warren Kamari. Welcome back, Warren. Incidentally, did you ever get your benchmarking setup running?
Yes, I did.
Cool. Cool. Well, we'll spare a couple of minutes at the end to let you tell us about that. Very cool. All right. So if you're not subscribed to the Bmwg mailing list and you would like to do so, there's a link that you can go to and get to that. Obviously, all our slides are available on the meeting materials page. So feel free to grab all of them. And there's actually going to be probably, especially in my decks of slides, there's going to be backup slides that you might want to refer to later. So feel free to do that. Okay, the note well, it's still early in the week. We have an IPR policy. It means that you have to disclose all your IPR in a timely manner. If you guys have a new draft today or some new material that's covered by IPR, please let us know. And also follow the various processes here with all these BCPs. Any questions about that? A contribution is not just a draft or an email to the list, but it's anything you say at the microphone.
There are a lot of new faces in here, so if you don't know what the IPR is all about and you don't want to raise your hand now, I didn't the first time either, so come see us afterwards. We'll run you through.
And here's a quick thing. How many people are attending Bmwg for the first time? Welcome, about 6 or 7. And Warren, did you want to say something?
So yeah, in addition to what Elle and Sarah said about the IPR stuff, please go read it and talk to your legal folk and stuff if you don't understand it. Don't just rely on what they said.
Very good.
Vote of confidence there.
Oh, no.
I know.
So here's our agenda. First we do status, and we're going to look at our new charter. And then we've got this one draft, which is, I think it's been working group accepted, actually. At least that's what I did the last time, but the draft name doesn't reflect that. So that's on EVPN PBB. We're going to look at the VNF benchmarking methodology, which is now about automation. according to Raphael. The title has changed. I didn't change it here. Sorry about that. Consideration for benchmarking network platforms. Actually, Jacob's going to talk about that in the online agenda. I fixed that. Benchmarking for modern firewalls. Is Tim Winters here? Yes, Tim, welcome. Thank you for joining us and for filling in for the rest of NetSec Open. Much appreciated. I'll talk about the back-to-back frame benchmark, which is followed up with some real testing. And this is what gets everybody exciting here when we really talk about laboratory work that's been done. And right behind me is Paul Emmerich, who's going to also talk about real stuff and the implications of the real testing on traffic generator calibration, accuracy, and precision. So that's our planned agenda. What I'd like to do is I'd really like to get to item 7 about 20 after 2, something like that. So that gives us about 40 minutes for the testing stuff, which I think is going to get really interesting and raucous. So let's leave plenty of time for that. And 2 minutes at the end for Warren to tell us about his benchmarking experience. Okay, any questions about the agenda? Any bashing needed? Everybody's looking at their laptops. Let's move on. Okay, so here's the quick status. The SDN controller drafts for benchmarking there approved. Hooray. Congratulations to the authors. Sarah was one of them. And I suppose the that approval process will not approval, but the editing process will continue now. So you'll eventually be contacted by the RFC editor to clarify a whole bunch of stuff, I'm sure. Nothing goes unscathed there. So the proposals keep coming. I've already talked about these. Industry discussion topics. This is what's going on everywhere in our industry. We're talking about buffer sizes, the assessment of them, search algorithms, and traffic generation calibration. It's actually happening everywhere, but we've got some good talks on all of this today. So here's our current milestones. Excuse me. And let's see. So the one that we originally planned to get going very quickly was in August 2018, methodology for next generation firewall. I think we're probably going to be a little bit behind and miss that, but that's all right. All of these were really aspirational. And the next step here is I wanted to mention that in our rechartering discussions, basically 2 things happened. One is that we codified our permanent attention to the virtualized network platform benchmarking here. That's now sort of a written part of our charter. It was always it was a bullet item for the last 3 years, and now it's an explicit part. When we where is it? Oh yeah, the one in the middle there, draft on selecting and applying models for benchmarking to IESG review. That was actually the thing in our charter where we got the most comments. It actually blocked the approval of our charter for a while. And, and the reason that happened was that, in fact, there's lots of models being prepared for network services and possibly applicable models being developed around the IETF that we need to pay attention to. So we have this draft on the table. It was updated. It was updated back in May, actually, but the author, Sean Wu, didn't send anything to the list about it, so it actually kind of surprised me to see the update there. But we're still looking at this topic, and what we need to do, though, is look a little more broadly than the proposal we received. That's the feedback we got from IESG. It's good cross IETF feedback. Otherwise, we might get all the way up there with something that is just going to get crushed with discusses, blocking comments. Any questions about the milestones? I think actually that draft on selecting and applying models, we changed that to December 2019 too, so I'll fix that next time. All right, nothing on that. So we did our charter update, as I mentioned. We have a supplementary Bmwg page, thanks to Sarah's efforts at restoring it. And we sort of keep track of the work proposals. We've adopted the work on EVPN, PBB, EVPN, but we still have to have more review of this and more comments and so forth before we go further with it. It's definitely on the charter, though, and so that's good. The rest of this stuff is kind of represented in the charter as well, although we haven't seen much on SFC, service function chaining lately. And actually, VNF is going to have to be retitled VNF benchmarking automation. So that's actually evolved a couple of times here now. Back-to-back frame, service layer abstract model should have been titled. Actually, that's what the draft says. So that's what we have. And next generation firewalls. So we sort of keep score here. It helps to organize. We also have a standard paragraph that helps people understand who review our drafts from outside the area. This is kind of like, this is testing for the laboratory. Security people, don't flip out because we're saturating interfaces and stuff like that. I mean, it's just advice to the world that if you haven't read our charter, it's kind of encapsulated right here in these few sentences. So when we write drafts, we try to include these. Another key point, and I'll mention this later again, but there's a new draft on, not draft, an RFC on our requirements language. Our definitions of words like must and shall and recommended and not recommended is actually kind of a new one. All those terms were originally defined in RFC 2119 by Scott Bradner. And the original version of that was actually developed here in the benchmarking methodology working group. But RFC 8174, which is fairly recent, improves that terminology and explicitly makes it clear that when those terms are used in a draft or an RFC in all caps, that means they take on the meaning that appears in RFC 2119. So shall is a requirement, an absolute requirement. Must is an absolute requirement. And when you see those capitalized words, that's exactly what it means. That's now clear with 8174, and there's slightly new version of this typical terminology paragraph. So I encourage everybody to adopt that. I just had two drafts go through the IESG and got dinged on this for both of them. So I went back and fixed all of my stuff, and I encourage all you draft authors to please do that. And that's it for the chairs. Unless you want to add anything there, Sarah. No? Okay. Good. Well, this thing worked astoundingly well. And so we will now ask Sudin. Jacob's your last name. Sudin Jacob is going to come up and please talk about your draft.
Thank you.
Very well. Oh, here's your clicker, but don't click it yet.
Do we have remote attendees?
Pardon?
Do we have remote attendees?
I still can hear you.
Do we have remote attendees?
Remote attendees. Yes, we do. Yes, we do. We got Brian Monk
Oh, I see.
and Lorenzo's part of the team.
And Sam.
So welcome, remote attendees. And all right, so we're done. We're mostly done with this. So now we can go here and press this and press this, and we're going. Oh yeah,
I'll log in.
Sarah's going to monitor Jabber, but there's really lots of ways to do this now. I still can't access it. Yeah, corporate thing.
Yeah, shall I start?
Please.
Please
Yeah.
do.
Good afternoon, everyone. My name is Sudin Jacob. I work for Juniper Networks. This draft is EVPN, PBB EVPN benchmarking. So EVPN and PBB EVPN became the RFC in best work group, and it is widely deployed in service provider network since 2014. It started as a draft, then it became RFC in 2016. So it is widely deployed. So there was no benchmarking criteria to rate this particular services when deployed into different service providers. Mostly the service provider consumed this EVPN MPLS and PBB EVPN. So we defined certain parameters to benchmark this.
Which button are you pressing?
Oh, yeah, got it.
Just the arrow. Yeah, okay.
I was pressing the other one. Okay. Okay. Yeah. These were the comments received from the previous, IETF. So the terminology sections, expansions, and the ordering of the test cases and the objectives. So, the placing of terminology section above the topology, and the topology requires some more dig into it. And so these were all the comments. So we have addressed that. And these are the basic, we have defined certain parameters. We define 8 parameters to benchmark these services when deployed. How to differentiate, one particular when you DUT when we are testing a one particular box from other. How do you differentiate this? So based on this particular parameters, we defined it. Based on that, we benchmark this. So it is based on the MAC learning, the MAC flush, the MAC aging, high availability, ARP scaling, the scale and the scale convergence, and the soak test. So these are the parameters we defined to benchmark these services. So based on that, it will be, tests will be conducted, and the measurements will be taken, and it will be plotted and rated on how each box is performing it. So acknowledgement, thanks Sarah for helping us, and Al for the support, and a lot of feedbacks and back and forth changing this, and thanks Sarah and Al for this support. And next is adoption.
Go ahead.
No, go ahead.
So like I said, I think we've actually adopted this.
Mhm.
But we still need to see wider review, I think. And so let me ask right now, how many people in the room have read the draft? I see 2 hands. Any of those, actually anyone have any questions about this topic? No? Okay. All right. So, go ahead.
Does anybody in the room have routing experience, testing-wise, besides the folks who have raised their hands? So it'd be very helpful for the folks who have the experience to read. We'll definitely cross-pollinate this outside of the working group, but from an editor perspective, I'm helping Sudin sort of lock into place the different steps. So I think this draft, this version and the next version Sudin has coming will be really approachable, and I think you'd be able to go on and read this and say, yep, this makes sense, or no, this doesn't. But it would be very helpful if you folks would take a look and give us or give Sudin feedback ahead of that cross-pollination into the routing area. Hello.
Hi, Jim Utaro, AT&T. Just a question. So EVPN encompasses a family of services. One of them is VPLS, there's access, there's a number of different, so EVPN VPWS, EVPN FXC, EVPN VPLS. So when you talk about benchmarking it, is it specific to the EVPN VPLS with the multi-homing and all of those features? Or are you intending also to do these other aspects of EVPN?
No, because that's why we specifically said based on only 2 RFCs, that is the vanilla EVPN MPLS feature, that is replacement of the VPLS and the PBB EVPN.
So 7432 actually articulates the control plane to realize not only the creation of a VPLS, but also a VPWS and also an FXC. So I'm just curious, maybe you might want to, I mean, what I'm seeing is many people using EVPN for a lot of different use cases. One of them certainly is in the data center with active, multi-homing, and that's a huge thing. But there's a lot of people also using it for access, like bring these circuits across, layer 3 network and land somewhere.
That's a good point, Jim, but because that is beyond the scope of it, because FXC, you know it, right? It is, it's a point-to-point, you're bundling the ACs. So here, because we are benchmarking the parameters for EVPN vanilla features, so it will be totally different. That's why.
I understand, but it's, I guess EVPN FXC takes VLANs and treats them as state and advertises that state to the next hop and says these VLANs live at this next hop in this context of FXC. So, if you're looking at programming that on a box, and that's part of the EVPN scope, that might be useful to people.
But currently, anyway, that's a good point because that cannot be taken into the VPLS per se because the parameters we defined it. That's a good point because the FXC came later. It's still running as a IETF draft 00. Earlier it was individual draft. Now they adopted it 00. I'm sorry.
You're saying that
Yeah, this is basically benchmarking this RFC because it's widely deployed since 2014. So we want to make this as the platform. Then this add-on services come. So we are benchmarking the base RFCs. These two.
So
Thanks,
I think,
Jim.
So I think what I'm hearing Jim say is we're not clear, or you're not clear on what your scope is in the draft, and could you clarify it? Would that be correct? Slash, I think he's also maybe potentially saying you may want to consider a larger scope. And I think as an author, it's your right to not do that. However, you also made the point. So my comment as a personal contributor, if you're going to say it's been widely deployed since 2014, I think Jim just laid out two very typical use cases. You may want to consider one, I agree, define the scope, but I do potentially think maybe you should broaden that scope because it's been out there for 4 years. So if we're going to put out something that says here's how you benchmark it, you'd want to cover the use cases of what folks are deploying, right? So if there's two widely deployed or two decently used use cases or three, then I think you might consider covering them.
At this point, I cannot comment. I need to think because the parameters, because the services, what Jim mentioned is totally different. What EVPN is kind of a super VPLS, and this is a point-to-point service with VLAN features and all.
Sure.
So the parameters will change, but I need to think. I cannot comment. Jim, I take your point, but I cannot comment at present because I need.
Yeah, that's perfectly fine. I want to make sure we're capturing the feedback correctly and giving it to you, and it's totally your right to take some time to think it through and come back. Yeah.
Jim, I really appreciate your point. Just give me some time because, I need to think. I'll get back. Because at present, I'm really apologize. I can't give you the comments on that because the parameters I need to think. Because you know it, right? The services are different. But it works on the EVPN. But what are the key points I need? Give me some time, Sarah.
Sure.
I'll get back. Thank you.
So that's a good ending point, I think. We'll sort of leave it to you to think about this. There's two ways to proceed. We could add this stuff to your draft if you prefer to go that way, Sudhim. But also, it could be an additional effort that folks propose if they see a need for that. So that's it could be a sort of a part one and part two kind of approach here, and I think that could work well.
Yeah, that's a good point because anyway, services are deployed a little bit different. So I need to think and how to add. I'll sync up with you later, Sarah, how this can be done.
Okay,
Yeah, thank you.
thank you.
Thank you.
And you can hand that to Jacob, who is up next. And then we go to here.
Uh-oh, you're an expert now.
Yeah. Oh, enough people scored and I read all the working group chair mail. Well, I got it right.
All right, great. So this draft is on benchmarking basically virtual networks or virtual network platforms. So as we've gone through, this actually says MVP 03. The draft there currently is actually MVP 02 because we missed the cutoff by like a few hours. So I have some slides on the work in progress of what's coming very soon, as soon as we can submit again. But for those that haven't seen or read the draft, we're really looking at how to benchmark the network overlay and and how to benchmark when that actually lives in the server world. Right, so there's lots of different considerations when actually benchmarking where the edge of the network is now within the server, connected to VMs or containers or various different other workloads that are out there. So I'm really looking at application layer benchmarking, the different tools and tool sets that we can use for that. So some of the changes. So one thing that I think Samuel, the co-author of the draft, did, we went to the NVO3 working group, BOF, and kind of talked a bit about this. So one thing that's actually coming in this next revamp is quite a bit of changes in actually some of the scope as well as some of the terminology. So when we look at the NVO3 draft, specifically the architecture for network virtualization over layer 3 or the split NVE control plane requirements, those aren't really covered or clarified as well in the scope. And the scope was kind of ambiguous because before we did that. So I think with us aligning the terminology to what's already there in the NVO3 working group, it'll make this draft a bit more clear of what exactly we're going after in terms of benchmarking. And then once we update the actual, the terminology as well in this, it'll nicely align. And then one thing, the split NVE is one thing we haven't covered that we're adding in. It's kind of a work in progress. The split NVE is actually the network, NVE, for those unfamiliar, it's a network virtualization edge. So the split NVE is when it's split between, say, part of it's living within the server and part of it's living in the top of rack switch. Is probably the most common example. And there's a lot of control plane considerations that go along with that.
Okay.
You plan to be very specific on your, what's being tested and where it's being tested, yeah?
Yes, exactly. That's
Okay.
what there needs to. That's exactly why we want to kind of define in each test, like here's if it's co-located with the hypervisor versus split, and have kind of different considerations for each.
Okay.
And that's kind of the big updates that we're going after in this. Specifically, I mean, if you look at the 8394, there's some ambiguity in how things come to an agreement. There's literally the one sentence that's like, okay, when they come to some sort of agreement. And it's like, okay, that's an interesting, yeah. Okay, so we need to kind of come up with benchmarks to say, okay, okay, I get it, this ambiguous, and every implementation is different, but how do you benchmark it so that you know exactly what's happening when it happens for it?
So Jacob, this is the sort of talking about the overlay layer.
Yes.
In the previous slide, which I don't even want to try to go back to, yes, there you're talking about application layer benchmarks.
Yes.
So we've got kind of this, we've got overlays and application layer. I'm trying to get the scope clear in my head here. It's got application layer stuff and overlay stuff, which is, I don't know, I'm not sure how that fits together yet.
I think the application, I mean, you could call it application or layer benchmarks, but I think the goal is to define also some benchmarks that when you're benchmarking from a server itself, how those benchmarks change. So instead of just having a traffic generator that's blasting traffic that's unstateful, you can actually go in and, okay, here's what are the application layer benchmarks you can do to actually benchmark this in a different way. I think that's the thought behind it.
Yeah, I mean, I have read most of this, and
Yeah.
I think I see where you're going, and,
Okay.
and let's work on some additional words.
Definitely,
I've
yeah.
got some comments to share with you,
Okay,
but
cool.
but that's the first one. I mean, it's usually all about carefully defining the scope, and then we can
Yes.
easily do this.
I agree, and that's I think the comments I put here is like the scope. The most comments and questions around clarifying the scope. So we're
Yeah.
hoping if we can go actually use the NVO3 working group and the RFCs that are already defined there as the scope, then we can kind of get to something that's more kind of clearly defined.
Okay.
So I agree, though, the application piece needs to be outlined there a bit closer.
Well, you've got some
more
good
carefully.
stuff about that. I mean, but what you're talking about is transport layer, I
Yeah.
think. Yeah, TCP.
Yes,
Yeah.
exactly. So a few things. So from 8014, which is the architecture, the updates that you'll see coming shortly are from the terminology standpoint, aligning to the terminology, and additional updates around attaching and detaching state and the state changes, specifically when the tenants are like, I mean, say VMs are coming up, VMs change. It's also clearly defined in the 8394 for the split NVE as well, where the VM state changes are creation events, migration events, termination events, all of these things. So we're kind of increasing the scope from just here's the traffic pattern, but how do you benchmark the kind of that state changes?
So these are like life cycle events.
It is, yes.
Yeah, and it actually says it right there.
They are. Yeah.
And we haven't had any benchmarks on that kind of activity before. So that's a great place for this to do some expansion for us.
Yeah, exactly.
Do you plan on bringing test results in?
Yes, absolutely. We
Well,
have a
thank
bunch.
you.
Cool.
Great. So look forward to the next meeting when we actually have all the drafts officially submitted again, and then we'll put some test results in there.
And just to get it out here, it looks from what I've read and what I see here now again, this is purely hypervisor focused. A lot of the world is thinking cloud native and, Linux containers and other
yes.
management systems. So, but that stuff's not there yet. The hypervisor stuff is here now.
Yeah. So they, even in the 8014, they kind of call that out as well. It's like these things could be used for non-hypervisor workloads, like just native container workloads.
Okay.
But it's very specific to hypervisor today.
Yeah.
But I think they have to do even further work to get to that point where it's container. But I mean, it's there actually in the world today. So it will have to work its way in there now. No worries. Yeah, but that's pretty much all I had. How many people have actually read this thing or have taken a look?
I have.
Few? Okay. We appreciate any more input, feedback. But wait, as soon as it opens again, we'll submit this new one. Is it open now? Okay.
Yeah, it opens Monday.
Oh, okay.
Yeah.
All right. So I'll submit it now.
So when you
and get
submit
it
it, do you mind sending a note to the
Yes.
list?
Send me the list. And I will promise to send my comments on O2.
Yeah.
I will send mine.
Okay.
I'll agree.
Awesome. Sounds good.
All right.
All right, cool. Thanks.
Thank you.
Thank you.
Any other questions, I guess?
Yeah, but for the folks who've read it, or just have some general questions?
Rafael, University of Campinas. My only concern is, like I'll say, initially I think I read the draft like 6 months ago, but my main concern was about the approaching not only VMs but also containers. So I thought that the draft was like very focused on the hypervisor, but if you bring that word hypervisor to containers, it might change the terminology a little bit.
Yeah, absolutely. I think, yeah, definitely. I don't know if it's if in this scope of this document or if it's like then containers or other workloads outside of the hypervisor. And if there is no hypervisor, what does that change from? Because I'm going to be very specific around like, okay, here's the well, for the split, there's a TNV and NNV and the NNVs and this external NV thing, and there's very specific things to like, okay, how the hypervisor does this with this. So I mean, it's if we go this direction, it's going to be hard to decouple it and say, okay, now here's the container thing. But I agree, there needs to be a separate container work effort.
Yeah,
as
I
well.
don't know how to do that, but it's just an idea about it. Maybe another draft, or I don't know how to.
Yeah, I agree. I think if it was if anyone's interested in taking on that work, I'd after we finish this one up, it would be really great to have kind of that follow on to the container networking or container plus. I mean, there's a bunch of other things that have to go with containers and
No
service
more
meshes
use
and
of
everything else.
Yeah, so I agree, just with a personal hat on too. I think getting through this, we'll set the bar and all the bumps we're going to work out, and then how and what applies to containers or what new stuff comes in afterwards, I think is a better round two and a new doc.
Yep.
Good.
Thank you.
Any other questions? Thanks.
Thank you, Jacob. This one. So that's this one. And oh, that's not right. That's not right. Oh, I missed one. All right, let's go back here. Next generation firewall. Okay. Tim, welcome. Since this is your first time doing this, you have to stand in a pink box. That's pretty obvious, right? You click the clicker.
Got it.
The slides advance, and everything hopefully goes well.
Perfect. So this is next generation firewall benchmarking. This is actually the work of a group called NetSec Open. It is a group of about 15 individuals who are working to getting together. We get together once a week, have a conference call, and talk about these types of test cases. So we've done 2 drafts. So this is the 3rd rev. I'm really going to focus on the differences that we've had, but if you want to ask any questions about any of it, feel free. There might be some of the test cases where I'm slightly less involved, where I might defer. I'll go back to the group and come back to you guys if you have any specific questions. So the first thing we did in the 3rd version of this draft, we reordered it. So if you look at the diff, it looks like a mess because we deleted like entire sections and moved them to the bottom and moved them around. So the diff's kind of hard to read. We're sorry, we won't do it again. This was a one-time thing. So there's a lot of reordering, so it makes it look like there were massive changes. The only other section we touched editorial-wise that was worded kind of funny because it was different authors and this kind of gave it one voice. So 7.7 through 7.1 got a little bit of a rework. Those are mostly editorial changes, not major. Detailed test cases. 7, we had a bunch of test cases, in particular HTTP throughput and HTTPS throughput, and we removed the binary search requirement. After talking to some of the test and measurement guys, this was kind of overly complicated. It was just easier to take out that requirement that we always do a binary search. So we removed that from the version 3 of the draft. We cleaned up the objectives of 7.2 and 7.3. In particular, we had a spirited conversation about object sizes, and those are the ones we settled on. If anyone has any feedback about those types of things, feel free to read the draft and send comments or get up to the mic. Those are what we've chosen for now. The second version of the draft did not have any real test cases for 7.3 through 7.6, so those are all brand new in this draft where we wrote down the individual test cases. So we're closing in on getting some of these wrapped up. Some of them also, it's sort of a rinse and repeat situation where once we wrote it for one technology, we could just input the different parameters, just made it pretty easy. So once we got the general setting up, we were able to update those test cases.
Before you leave that one,
Yep.
Can you say again why you removed the binary search requirement? I guess I missed that.
Overly complicated was what the test and measurement guys were very concerned. In particular, we work with, this group includes Ixia, Spirent, those types of test and measurement vendors, said the binary search overly complicated some of the results that we were going to have to get out. Like there's easier ways for us to get to the throughput instead of actually making a binary search be done for over all of the sets of results. In particular, it's not easily automated, was their explanation, so we just removed it. I think the current text is, fluffy is not the right word, I think it just says how you get the value is sort of up to the tester, how they want to go about getting the individual throughputs.
All right.
We're more than willing to take feedback on that.
I'd love to talk about that.
Sure.
But let's talk about it after you see all the stuff that we've just done to try to improve binary search.
Okay. I'll be riveted.
Well, probably not. You'll probably say, yeah, that doesn't help.
Yeah, I mean, that's sort of what we started to go down that rat hole and decided that for the moment, we just took out the text because we didn't think it was it was stuck in there. I don't think anybody felt super strong about it.
Okay. All right, good.
So, going forward, I don't know how many people have read the draft. Obviously, we would love to get some on-list revision. I will say there is lots of review going on inside of this group before it gets listed. There's, like I said, there's somewhere between 10 and 15 participants who are reading these test cases as we write them, but the more the merrier.
Well, and let me just say that there's another way to do this, and that is, I mean, you guys have face-to-face meetings, but if people were willing in this group to join our mailing list and to share comments that during the development of this, that will look a lot more. It'll look a lot more engaging to our group. The folks who are kind of being just presented with a big document once in a while.
Yeah.
And activity on the list is the best way to get some attention. Get some additional readership. So
I think we're getting to the point now where the test cases are stabilizing that I think we should start to move the conversations over. I think before we were working out lots of details, might have killed the list, but I think maybe after this next revision, I think absolutely they should start to do all of the stuff on the list.
Great.
Again, like you said, just to show interest, because there are people that are interested in working on it.
Absolutely.
Yeah. So I will make that suggestion
Join
back to that
the
group.
group.
Yep. We're working right now. One of the things missing before we think this is ready to go is it doesn't have the security effectiveness. In particular, you're talking about vulnerabilities and things you need to do. The list is close. We have an idea of what we want to say about this or how we're going to go about getting that list. So that'll be in the next revision of the draft. And then we missed a couple. We still have one test case that we didn't make it to the draft. So we'll get that in the next go around.
Okay. Very good.
If anyone has any questions, I don't see anyone running to the. No one's running to the mic, so I think we're going to be. Oh, you are coming for me. All right, go ahead.
Jacob Rapp, VMware. So this document itself is really focused on like a physical appliance-based firewall, correct? I know you talked NFV thing as well, but
yeah, it doesn't specify it. I would say I think most of the people involved are thinking hardware box, but a virtual firewall could. run this test, could
Okay.
run these test cases.
Because as soon as we go virtual firewall versus a distributed firewall, two different things as well, like a VM firewall base versus an agent in a
Yes.
guest versus something living in the hypervisor are very different.
Yes, absolutely. So in our case, I think we're really thinking more self-contained,
Okay.
not distributed firewalls.
Okay, is there worth like noting in the scope or something, like just as is focused on?
I was just trying to think about that when you were
I know how
asking
that
me.
would
I don't know. I'll have to go back and read it. I will go back and read it and make a note to myself if I think we're not specific enough about what we actually mean when it comes to that. Because you're right, a distributed firewall is an entirely different situation. So I will make sure that we're very clear about what type of firewall we have listed in there.
And there was a point I wanted to make while you guys are facing each other, and that is when you were thinking about application, quote, quote, TCP layer
Yes.
benchmarks, that's some of what this team is doing as well.
Yeah.
So there's some chances.
Yeah, that was
for
my
us-
follow-on, actually.
Oh, good, good. I'm sorry to interrupt you.
Well, absolutely. I mean, I think that is where we can look at some terminology and definitions.
Yeah.
That would be awesome. Like just like things like what does stateful mean? Like there's everybody has a different definition of stateful, and it seems like it should be something that is clearly defined.
We can agree on. Yeah,
Types of
absolutely.
things.
I'll take a look at your draft to see if we can sync some of that up so that we're talking the same words for sure.
Cool.
Great. Sarah? Oh. Sorry. All right. Any other questions from the group? No. Okay. Well, thanks for the excellent progress. on
Yeah,
this,
the
Tim.
only thing they did want me to ask is what do we do for working group adoption for this draft?
So what
What are
we've
we
seen
thinking?
is not many people on the working group reviewing this.
Okay.
We've got to have activity, demonstrated interest, and then sort of like the last three columns of the work proposal summary matrix.
Okay.
And once we see significant support at meetings and on the list, and then we can start to ask for
Okay.
working group adoption.
Perfect. That's what I thought you'd say, but you can confirm. Thank you so much.
Very good. Thanks. Thank you. Raphael, I completely blew the agenda. You were supposed to go before Jacob and Tim, and I'm now going to demonstrate how it happened. Let's see here. So I got to back this thing up, and I thought I had them all in order here, but that's no. See, that's mine. That's mine, and somehow that one got missed. So let's see here. Yep, that's right there. It's that one. All right, so this magic button helps, and then
Cool.
this magic button helps. Cool.
Right? Yeah. Okay, cool. So I'm here to talk about the updates that we made in this draft, starting by the title. I think we had a lot of reviews in the last meeting about, okay, you're addressing generic ways of VNF benchmarking. So, and it's like based on the research behind this draft, there's a lot of focus on automation. So we said, yeah, we agree with that. I think that's some consensus we had. And then we changed the title for methodology of VNF benchmarking automation. So why we updated, basically the main changes were about automation, as we discussed in the last meeting. I mean, there's the new title, the scope was changed. We added some modifications in the methodology. The idea is that we do not aim to explore all the VNF benchmarking methodologies, but we aim to create this kind of like approach of methodology for if you have a VNF benchmarking methodology, we have the scope of how to automate that and create this skeleton of tools that we have this, reference implementations that we can play with. So, because we also have the idea that the VNF developer knows better the metrics and how to benchmarking the methodology. So if we provide all the tools and a kind of like a generic methodology for that to be automated, we understand that the developer can do that better than us. And I think that new coming VNF benchmarking methodologies might use this draft as a reference implementation for that. We have also new contributors from Paderborn University that are doing similar work as we are doing, with a reference implementation also added to the draft.
So if we can stay on that slide for just a sec. For me, the biggest problem I have with what's written here, it's a large part of what we want to be able to do in Bmwg is have repeatable results and have if I execute the test and you execute the test and we were to execute them against the exact same thing, we'd come out with the exact same results. The problem is if you leave the metrics and methodology up to the developer, I'm not entirely sure I trust my developers. I mean, I love my developers, but I don't trust them. And I
Okay.
surely can't trust but verify if I follow this methodology. So I have some sympathy. I think I've been at the receiving end of these comments. I think Al gave them to me once upon a time too. So I definitely have some sympathy there, but I do suggest maybe we take a look at how to have at least something be automated and give yourself some wiggle room, but something needs to be there so that I could repeat this and get the exact same apples to apples comparison.
Okay, let me get there.
Okay, sorry.
No problem. I mean, this is a generic, like, I think it's a major concern about the draft, how it can be not generic or not too specific about the automation. But I mean, and here's what we're trying to restrict it to have this like developer, or I don't know, this the creator of the benchmarking methodology to come here and specify what we call it the benchmarking descriptor, and this comes the final. I mean, the changes in the draft. Then we focus on, say, like, the main focus of the draft is to obtain a VNF benchmarking report in an automated way, and we do this by having the benchmarking report composed of two parts. One is the benchmarking descriptor, and the other is the profile. So the descriptor is the one that I give it to you, and you say, like, now you can repeat it, and it gives some kind of like boundaries and a strict kind of like environment and requirements parameters that you can say, if you put this in the environment that you describe here, it will give you the same performance profile. So that's what we're trying here. I know it's like we are in a 0.2 version, but we will get there, I hope.
Okay.
So then in the benchmarking descriptor, mainly we describe the procedures configuration, the overall description of the benchmarking, the automated benchmarking scenario. The target information is about the VNF itself, the version. I mean, the target VNF, the version, the model, all the specifics of the VNF. We have the deployment scenario that basically, I forgot to tab here. It's basically the topology, the requirements, and the parameters for each one of the components that we have described in the VNF benchmarking setup. This is in the draft. And then we have the VNF performance profile that it's the result of the execution of the benchmarking descriptor. I mean, it gives you the execution environment. That means where the benchmarking descriptor was put and how it was executed to create that. So it gives you hardware specifications and software specifications. This is also detailed in the draft. And also the measurement results. We put the measurement results as active metrics and passive metrics. The active ones are from the direct relationship of agents and the VNF, and the passive is the monitored or the inferred metrics from the VNF when it's possible. So here's the basic, scenario.
Hang on just a second. Could you go back to the last one really quick?
Yep.
Where I think in the benchmark descriptor is where you would have information that you're going to basically send to the traffic generator and receiver.
Exactly.
So which one of these bullets covers that?
The requirements and the parameters.
Okay.
Yeah, we have requirements and parameters for each one of the components inside that. And I mean, when I say components, is specified in the considerations of the draft. Like we classify the components as manager, agents, and monitor. So it would be a parameter for the agent, like the packet tracing being used, the rate, and all the parameters of the tool. And this goes also for because we have this idea that the agent can have attached tools to it, and we call them probers with specific interfaces to these specific technologies, like MoonGen, for example.
Yeah.
And then in this case, you just need to specify how to attach MoonGen as a prober into agent and put the parameters to configure that. And that goes as a requirement for the test itself. I mean, you must have an interface to an agent with MoonGen, and you must have parameters to execute with certain, I'd say, generic guidelines and packet traces.
So then one comment I came up with as reading through, I saw this term prober, and I think in most of our literature in Bmwg, we've called that device the tester.
Okay.
So, or the traffic generator or something
Okay.
along those lines. So it's probably better to pass through here and try to use as much well-known terminology as you can, because you're inventing a lot of new stuff in order to bring this automation
Yeah.
framework to life. But if you can hook that to terms we all know, it'll improve understanding.
Yeah, I totally agree with these new contributors now. I mean, we have a lot of cycles of, I mean, modifying the draft and giving new ideas, and the terminology was changed from the last draft, and I
Right.
think it will come up to change again. So nothing is written in stone in the draft. So basically, the idea here is that I told you, have this picture of, you know, you give the VNF benchmarking descriptor as the definition of the method, how to benchmark the VNF. You have the benchmarking process, and it generates the benchmarking report that contains basically the descriptor and the performance profile. And with all of that, you can compare, repeat experiments for this benchmarking descriptor. In this case, we consider in the draft that multiple steps or procedures of this benchmarking, of the benchmarking itself can be automated, and we define like the orchestration of the components itself, the placement can be manually or automated, put in a manual or automated way, the management and the configuration of the components also, and then you have the execution of the benchmark itself, and the output. We consider also possible ways of parsing the metrics in a raw format, in a specific format, extracting some new analytics ways, for example, clustering metrics or so, that might be specified in the VNF performance profile. And there are many issues that are unresolved in this draft. I mean, at least now we understand, the co-authors, that we have a good skeleton of items that we can work from now on. For example, we need to clarify the automated benchmarking procedures. I mean, what is happening actually in each one of the bullets that we have in the draft. We need to specify clearly each one of these particular cases in subsection 5.4. I mean, for example, when you have the case of a noisy neighbor, when you have the case of failures, or when you have the case of a flexible VNF, that inside the VNF itself, it might have multiple components that might scale depending on the traffic workload, and this must be represented in the VNF benchmarking report. Yeah. And so what's still missing? We think that we must detail these interfaces, like you said, of the agent monitor with the prober and listener. This terminology might be updated. We need to specify how these interfaces work actually in the draft. The action of each one of the components, like the manager, agent, and monitor, might take on the messages, and how they parse the actions that they must take to run the benchmarking, stimuli, and parse the metrics. The possible issues of the automation approach, I think we need to find that, like, for example, if you're going to put, for example, a binary search as some way of a procedure in this automation scope, I think we need to say, hey, this might be a problem here, and there. And I mean, as a consideration for the reader of the draft. In parallel, I mean, the co-authors, we are developing an information model that because we have this reference implementations, Jim, the one I coded, and the other one, TNG bench from the manual, the other co-author, and we are doing tests side by side, and we are creating this reference model, information model, that might be useful for the whole draft. I don't know if it's in this, as we talked earlier, it might be in the scope of the draft or not. We need to still see how we're going to put it inside the draft, or as a reference, I don't know, informative reference for the draft. And now I put that RFC 2119, but it's now 8174. So
It's both, really.
yeah, we are going to update the draft with that. I don't think we are still in the step to update according to that, because we have internal discussions about what we should, what we must, and
Okay. Yeah, that's always the kind of the most interesting
yeah.
stuff.
So
It's a real requirement.
and that's all.
Good.
So
Go ahead.
just one small note, I think you don't want to just a draft to be, your bottom point there about 2119. I think you also need to account for 8174,
Yeah,
yeah?
that's what we just said, yeah.
Yeah.
Oh, I'm writing, sorry.
It's okay.
Sorry.
No problem.
I had another question here. What about, I mean, GYM, the project GYM, GYM was an open source effort.
Yeah, the release is now scheduled for this next quarter, I hope.
Okay.
I have a PhD thesis on the same way, so.
And what about the
some point.
5G Tango guys?
This is already open source.
That's open source.
Yeah,
Okay.
this is already open
So
source.
there's some, the interesting thing is that there's some open source work supporting this.
Yeah.
And that's, I mean, that's going to be valuable because, you've got the specification, you've got tools that hopefully align with it, and then that means that this can land with some ability to do test automation, like right now.
True.
So that's, I mean, that's a valuable connection to make.
In the next meetings, we have the plans to bring the results here. I mean,
Great.
scalability, I mean, automation, timing, all precision, accuracy, all these issues that we might face in our tools. And this goes with the information model as well.
Cool.
So, yeah.
All right. Any other questions? The co-chairs have done a good job grilling you, but maybe someone else has something.
I appreciate it.
All right. Well, thank you, Raphael.
Keep it updated. Thank
Please
you.
keep up the good work.
You're next.
Yes, I am. All right.
All right, so while Al is loading his slides, where are the blue sheets? Did we get it back?
I don't.
No?
I don't.
Yeah. One is out there somewhere. You can take a look around you. Maybe it gets left on a seat. Ah, has everybody signed the blue sheets? If you haven't, could you raise your hand? Just want to make sure we capture your signature. Thank you.
All right. So this is the draft on the updates for the back-to-back frame benchmark. This is where we're desperately trying to measure the size of the buffer of the device under test. And RFC 2544, our most fundamental RFC, specifies a method to do this. The thing we're trying to measure is actually the longest burst of frames that a device under test can process without loss. It's intended to examine the extent of data buffering. The material there was extremely concise in terms of the procedure and reporting. In other words, there wasn't much there. It was like one page. So we ran some tests in the VSPerf project as part of the open platform for NFV last year, published the results at the summit. And what we basically decided there was that quite a few considerations could be improved. I've skipped over a lot of those here, but the main one is this idea that when we measure the longest burst that a device can accommodate, while that burst is being transmitted into the device is also forwarding packets, basically forwarding frames. And the previous calculation didn't account for that at all. In other words, by the time you try to assess the size of a buffer and you count the number of packets which have been sent, some of those packets aren't in the device anymore. They've actually gone out. So that's what the correction factor is simple, and that's what it's all about accounting for. So when we tried to calculate the number of packets in the buffer, we calculated the average length of this burst, the number of back-to-back frames. We divided it by the maximum theoretical frame rate because they've been sent at that back-to-back rate. And that gives us basically the time of that is represented by all those back-to-back packets put together. But now I've explained the second part of this, that basically we know that the throughput over that amount of time is going to have extracted, the maximum throughput is going to have extracted some number of frames. So that's why we have this corrected factor here. So we have the implied buffer time, and we correct it by this fraction, which is the measured throughput over the maximum theoretical frame rate. And it turns out that reduces the buffer size quite nicely to something that's more, probably a little closer to accurate. Now, this test only ever intended to work with a single egress port where we're sending traffic, and a both a single ingress and egress port. So it's completely different from the test that was described in the data center benchmarking, 8239, I think it was. That's where multiple ports were used. So here's the improvements. Mr. Yoshitaki Ito corresponded with me, and what we saw was basically we needed some text to clarify in the draft what these parameters are. All the stuff that I just mentioned and waved my hands about, now that's explained in the draft. So that's actually better. And we've also described the potential benefit of using the correction factor. So, and then finally, we've clarified in the scope that this does not apply to these multi-port and the data center techniques that were defined by Jacob and Lucian in RFC 8239. So we had some questions in the draft for discussion, and we said, should this particular search algorithm be used? We think yes. The answer is yes. We think it should probably be binary search. And also, should search trial repetition, should include trial repetition whenever there's a loss observed to avoid the effects of background loss, unrelated to buffer overflow. So now we're thinking of two kinds of sources of loss here, kind of a transient loss that might be present on the links, really high-speed links, or in the devices itself, if it's a virtualized device. And so, yes, we think the answer is yes there as well. So we're going to see some results about that in a moment. So the next steps, who's read the draft? One hand, thank you. Oh, two hands, thank you. If you guys have comments, that would be great to hear about now. But otherwise, we need more readers before we can adopt this. We've got a milestone on our charter, but we can't adopt this if it's, and of course, I'm speaking as a participant now. I'm glad to qualify that. Other ideas are always welcome here for doing this kind of benchmarking. We'll hear more, I think a little more about that later too, possibly. So, comments?
Are you clarifying the draft to state that you're only expecting one egress port?
It's always been an RFC 2544 thing. I could do that, I think. Maybe I'm not sure whether that's in there or not, but it's definitely clarified that it doesn't apply to 8239.
So I think clarifying it is good, because literally non-IETF, just with my day job hat on,
yeah,
we're running into this a lot from customers who are asking us about buffer and how things are run. And there's generally no box that's left anymore with a single, with memory per port. It's a shared pool.
Okay.
And so while I applaud and I think we should have this refinement, don't get me wrong, I do think it sort of begs the question, but how big is the pool and how big is the buffer when it's shared across end ports?
Right. So, Jacob, go ahead.
Yeah, actually, that was pretty much my question. Was it, it's kind of like I think the scope, I mean, maybe correct me if I'm wrong here, is like it's a device is not actually capable of doing full lane rate. So then you're able to, that's where we're worried about that. But I do agree with Sarah with your point that, okay, what about multiple ports going at the same time with one ingress?
So we've got a good taxonomy here. We've got devices that can't perform at full rate, and their single port testing is enough. And that applies to a lot of the virtualization world, frankly.
Sure.
I mean, that's why benchmarking is cool again. All this virtualized network function stuff. All right. So So that's a good clarification. Be sure you type it there so I can see it again sometime. We've covered your point, but my next slide here, procedures. Now, don't go away, Jacob. Oh, yeah. So Yoshiaki Ito sent to our list this examination of the buffer testing that he's been running in his lab. And he was sort of thinking that there might be some ways to clarify what is currently in RC 8239. So now we're getting into the test results here. What Yoshiaki is showing us is he's measuring latency per frame, and he's got 1% rate on this combined set of ingress ports, which slightly overscribed the egress. And so he's tracking the delay there. And when he first sees loss, he's saying, okay, that's 24 frames, so that's the latency. Any thoughts on this?
Yeah, so there's just something about that diagram that rubs me wrong. The buffer scope on like any box, at least physical box that's shipping today, sure as heck isn't being just restricted to the one link. It would be, you would most likely see packet drops across both.
Yeah.
So when I saw it, I wanted to digest it a little bit, but since you ask, I guess it's now knee-jerk coming out. I'm not sure I don't think it's as simple.
So he's got more diagrams.
Oh.
And here's one. So now he did 100% rate on 2 ingress ports, and he tracked the same latency. And what he basically sees here again is 24 frames for each of them.
Right, because when you see the inability, if it's going to drop on one, it's going to drop on both. That doesn't surprise me at all.
Yeah. So he kind of expanded his methodology here to be able to track the latency and the loss in both of these separate streams.
Yeah.
He's got one more where he did 3 of them. And now he sees, oh, look, now the buffered frames are 12, not 24 plus. So,
Which is exactly why we, in the RFC, we put that you should be doing these tests with multiple ports and multiple iterations of the ports and multiple latencies or multiple ingress rates. That's exactly the reason, right? Because you're going to see different results depending on what you're going to do. As long as you benchmark all of them, then you actually have a clear view of actually what the buffer's doing.
So this is why you've got multiple iterations of this
Exactly.
test in 8239. Yeah.
And multiple iterations, but not just multiple iterations, but also multiple combinations of ingress and egress ports.
Yeah.
Because I've seen some devices that have 4 ports per buffer. So when you add a 5th port, it completely changes everything else because the ingress of the 5th is taking up more buffer. I mean, same thing with this, right? So this is exactly what we want to see actually.
Yeah.
These results.
You want to make sure that those egress ports are all on the same buffer, which, just personal hat on for a sec. We're finding that to be all over the place. They're not laid out the way you'd think they'd be laid out at all. So, yeah.
Yeah, it's very different.
So you have to test to find that out, I guess.
Exactly.
Yes.
That's why
Unless the vendor tells you, but
Right.
even then
Right.
you
I think
confirm.
that was one of some of the early comments when we did the RFC was that, like, what do you really need to do all these ports and all these iterations? Like, the answer is fortunately yes, you
Yeah.
do.
Yeah.
You can automate it, so you can script the heck out of it. So
Right.
Yeah.
Automation.
doable.
Raphael, get on that. All right. But, and just to distinguish it, I mean, 100% rate for one port to one port, that's going to go through here loss free. So you're never going to see a burst or whatever in this particular circumstance. He had to go to some level of oversubscription in order to create some
that's
buffering
just a
there.
box that can come forward at that line rate.
Yeah, that's exactly right. So, and the case I'm worried about is where you put, where if you put 100% of line rate here, now you see losses immediately. So you've got to back down from that, and that's where the burst test is worthwhile. So 2 different categories of things.
Yeah.
All right.
Cool.
Good. I think that was it. Oh, the reporting. Well, we've got good reporting. I already took care of that. All right, so that's it. Any other questions? I'm very thankful for the discussion on this, and also for Yoshiaki, who got in touch and is really doing some of the stuff. Glad to get this feedback. Thank you. So I'm going to follow up now with what I threatened to do, which was the OPNFV Hackfest Plugfest results.
Yes.
So now we've kind of reached the point where we're not talking about drafts anymore. but we're talking about measurements which are going to influence our future and development and so forth. And it's always good to bring this stuff in. We're always going to try to fit this stuff in. If you've got measurement results, then this is what we get excited about here. So let's do that.
I would drive it, but you're doing such a great job.
Yeah, and there's no question, no knowing what's going to happen if we change drivers here. All right, here we go. This thing has to be clicked, and then this thing has to be clicked. All right. So Sridhar Rao is the project team leader now of the OPNFV, Open Platform for Network Function Virtualization. It's a Linux Foundation open source project. He's the project team leader for the VSPerf, vSwitch Performance project there. And we've been contributing, I'm a contributor, committer on that project almost since it started. And we've been contributing to Bmwg for a long time. Got a couple of drafts as a result of it as well. So it's really his work, my work in the kibitzing and designing, and the VSPerf project team for keeping everything up and running. I mean, it's all of us really getting this stuff done. So here's the quick problem statement. There's lots of ways in which our test results and repeatability can be sort of threatened. When we test over time, over minor changes, identical nodes, different test management tools, and so forth, using different test equipment, we actually examined this as part of the Danube Plug Fest and presented some results here last summer and at the OPNFV Summit. So now we're covering the time aspect here. We were planning to do it with multiple nodes if possible. We did do some testing with multiple tools, but that's yet to be included in our summary here. So our initial focus was on search algorithms and looking at the search algorithms in ways that we could improve them so that we might improve our repeatability. So a quick view of the test combinations. We looked at some of the test configurations where we were already running continuous integration tests to give us some view of the potential issues we might see. But we used the T-Rex traffic generator in order to do this testing. The reason we did that was because we could easily control the search algorithm there. And basically substitute our own modified search algorithms other than the ones we had previously built. So a point I want to make about background here is that search algorithms can actually have different roles. The roles are sort of born out of the testing that they serve. If you've got highly repetitive continuous integration or system integration testing, then you want the test to run fast. And there's a proposal to do that in the FDIO CSIT project called MDR. You could also have multiple search goals that you try to collect while a single search is in progress, like a partial loss ratio and a zero loss ratio or a near zero loss ratio. There's another project, NFV Bench in OPNFV, that's using an algorithm that does that. But the one we're focusing on here is our traditional benchmarking role of reliable results in the purely experimental scenario. And we're focused on the zero loss throughput as the basis for this testing and as a basis for many other benchmarks. So here's a quick view of our deployment scenarios, which I will call phi to phi, as labeled at the bottom there, and PVP, when it includes a VM, and PVVP, where it includes two VMs. And the simplest scenario is this phi to phi case. It goes in and out of the vSwitch. But notice that our test device is always a physical test device. It could be MoonGen, don't worry. But it's always separate from the device under test by these physical interfaces. And that's to avoid the possible conflation of workload versus the test traffic generator. We've stayed with that. And believe me, these are realistic NFV deployment scenarios as well. You have one or two network functions, virtualized network functions, VNFs, or a VNFC and another VNFC that are working together. and they go in and out of the physical port. That's it. So we deployed the terminology from Test 009, which is an ETSI specification that we've had a chance to comment on here in our by liaison. And the way we've worked this is similar to our terminology of trials, where we are searching over many different load levels. What we've collapsed many trials with at different offered loads with into a single test, which has a measurement goal, trying to find the maximum throughput at zero loss, something like that. If we're going to repeat those tests, and actually we do that in this study, then we have sets of tests. And when we change any of the parameters, then that's part of a method. So I've illustrated here as a set of multiple frame sizes, but we test with fixed frame sizes. So this is actually, Raphael, this is something that you could include this set terminology in your hierarchy of testing too. I think that would be good. We're about to see the value of repetition at the test level. So, doing good on time. Oh, okay. So this is binary search. This is the day in the life of a classic benchmarking binary search. This is a case where we start out at 100% of the. Does this thing work? Actually, this. Oh, there we go. So we start out at 100% of the maximum frame rate. So that's the maximum theoretical throughput for a given frame size. And then when we see lost frames, something like 42 million there, you reduce it in half. That's the way the binary search works. But we have to go all the way down, in this case, we have to go all the way down to 6.25, and we, that's actually fairly low throughput. This is a P2P case here, phi to phi case. And we see this loss in the 700 range. Interesting. So we search around, and we end up with a value that's 4.28% of the total maximum offered load. And one of the other things that we saw here, the duration of the test. What that really means is that we were sending a constant number of frames to set our trial duration, and in fact, the device didn't deliver them at. I see Paul laughing. The test device didn't deliver them at the maximum rate, so this duration actually exceeded the 15 seconds that we planned. So it's good to have these checks. You always want to be testing the tester. And I'm stealing Paul's line, but that's more evidence of it here. I couldn't resist. This yellow case here, it's kind of an interesting case. And in the binary search, basically what we're, every time you're kind of changing your search area, and if you see no loss, you search above it. If you see loss, you search below. And if you have a transient impairment along the way here, like this one, I'm gonna tip the scales. This was actually a transient, and some of these are transients too. So when we see that, we greatly influence the future search, and how are we going to handle that? That's the problem.
So before you go on, Al,
Yeah.
doesn't the fact that trial number 4 and 5 at 12.5%, you saw 237 lost frames, but at can
Why
you
is it-
trust anything you're seeing at this point? I mean, that's crazy.
Why is it more?
Yeah.
At 6.5%.
Significantly more.
Yes, that's
Yeah.
exactly right. That's exactly right. That's kind of a tip that there's some sort of transient thing happening here. So we're going to combat that.
Okay.
But well spotted. So I should have said this first. In fact, I plan to switch around here. So when you have a search space, you divide it up into kind of like your minimum tolerance. And in this diagram on the top of this thing here, I've divided 12 megaframes per second into equal 1 megaframe per second steps. So this creates the search array. And what we're going to test for is whether loss occurs or not. And that's our indicator of whether the resources have been exhausted in our device under test. So I wrote this part in the draft about retesting and checking test results and should we repeat the results. But I went deeper into this after writing some of those sentences and talking to people about it. And what I found is this tiny little reference here at the bottom here, unfortunately. It's searching games with errors, 50 years of coping with liars. And that's exactly the situation we're confronted with when we have two different sources of loss in our device under test. So our questioner, I've drawn the model up here that sort of fits this what they described in this paper. The questioner asks a question. The question's delivered error-free to the responder, the device under test. And what we're basically asking there is whether the resource limit has been exceeded by the offered load that we're generating there. And when the resources have been exceeded, we answer with whether loss occurred or not. So if loss occurred, that's true. If loss didn't occur, that would be false. Now, there's a background error process, and that's the liar here. That changes the answer that the responder gives back. So an error converts a zero loss or a false response to true. But we're working with a system of half lies, and that's terminology from the Pelk paper. Only one of the answers can be influenced by this lying phenomenon. So if in fact we've seen loss due to resource exhaust and a background error process jumps in and causes more loss, that's not going to influence our search results. That's actually a very happy outcome because it means that we're not going to have to repeat all kinds of outcomes. We can trust all the false ones. We have to sort of retest all the true ones, the cases where we have loss. It's a time saver, and that's a good thing. And this is the timing of it. So what we're hypothesizing is that these transients that cause loss, appearing over time here, the red vertical arrows, if they occur during a trial, then we're going to see loss due to that. And on the other hand, if we repeat the trial with the right duration fairly quickly, now we have a chance to see whether that loss was true and it's really resource exhaust, or whether it was caused by transient phenomenon. But what's also clear in this diagram is you have to choose your trial duration very carefully. And that means you have to do some long duration testing. I'll try to get that in a moment. So a long slide here, but basically here's what we chose in this testing. Minimum step size of 0.5%. It works a little differently than the fixed frame size thing. We were looking at percent of the maximum. The maximum times that we would repeat a trial is 2. And we also created a loss threshold on repeating trials in the V2 version of the algorithm. We tested 30 seconds and 15-second durations, but that, as I said, that's actually best determined after doing some long-term tests. We did 64 and 128 frame size, and the maximum number of repeated tests we did was actually 4 in this, but I think mostly what I'll show today is either 4 or 3. So we also calculate these interesting metrics about our test. The number of repeated tests where the loss outcome changed. So basically this state right here. And we also look for a metric on consistency of the results, basically to be able to tell, is this repeating trial is actually doing anything good for us? So here's the long duration test that would be planned. We haven't actually done them yet. We actually need a better tool to do this. You can't just look at the results at the end. You've got to be able to see how much loss occurs and where it occurs in a narrow time space to be able to accurately plot this. So we've got more to do with that. So here's some results for the 64 octet and the 128 octet results. So I'll work through this search algorithm details with you. In fact, I'm going to do it over here. I'm going to do it right here. Sorry, you could see it, but I'm going to do it with I'm basically going to do it with a pointer, because that way it gets recorded. Where's the pointer? All right. So this is the phi-to-phi, what we call P2P case. And here we're looking at binary search with the number of received frames counted. This is the percentage of the maximum offered load all along here. So these are repeated tests at 64 octets. After we've done the binary search, this is the outcome. And the binary search always took 12 iterations. So that was true across all of these cases. All right, so let's look at binary search with loss verification. And basically what we do is exactly what I showed. If we see loss, we test again. And if we see no loss, we trust that outcome. We restoke the search into what it was supposed to do with zero loss and move on. And what that means is that now we're testing above a point in the search space where the loss was telling us to search below before. So the interesting thing is that with the phi-to-phi case, you remember this goes from the physical up through the V-switch and back out again. We're not seeing very much difference here. In fact, these are pretty consistent results in terms of the percentage for the binary search. And we're also seeing consistent results here for the binary search with loss verification. And the devil's in the details, isn't it? How many cases did we see reversal when we tested a second time? None. So our results for the phi-to-phi case aren't really troubled by this transient phenomenon. And that's actually very interesting news, because it tells us that when the transients come around to bother us, they're coming from someplace else in the architecture. So this was a very valuable result. So moving on. Oh, go ahead. Here, I'll just use this one. You guys can hand that one
Thank
around.
you.
Okay.
So at 64 octets, I agree, but at 128, it's curious. You see a couple of reversals, and your throughput, your loss verification ranges from 86 to 100%, which
Yeah.
is not at all consistent with what you saw consistently in the 64-byte octets. So I would almost argue, frankly, that I agree anyways. I suspect your transients are coming from somewhere else, but I'm not entirely sure you can say that with a straight face in the 128 octet case.
And we've only seen this once. Nah, that's okay. I'll just pick this up. We've seen this once in the actually we've seen it occasionally in the continuous integration testing, that once in a while, for some reason, 128 octets goes through at maximum throughput. It actually happens. And we've seen it in the burst testing as well. Occasionally 128 byte packets, for some reason, they make it through the architecture that we're testing here. So it's a real result, but it's a platform variability that we don't fully understand. It's clearly not caused by the phenomenon we're chasing and trying to remove here. It's something else. So it could be something that Paul's going to tell us about later. We'll see.
So back when we used to do 2544 on routers, there used to be that point where we'd see folks, vendors optimize their architectures for 64, or because they knew the 2544 test was happening. I'm wondering what happens if you were to do this with 65 octets or 129 octets.
Yeah, those are always interesting tests to run, and I think that's I think that's worthwhile doing. In fact, that's what the new spec we're writing in ETSI Test 009 recommends. So absolutely worth a shot for that. So let's look at okay. I meant to mention these are all 30-second trials. We chose 30 seconds because it was what we were currently running in our continuous integration test. But we didn't do any long-term testing yet. So we really had no idea whether we fit in between the transients or what was really happening here, okay? So now we tried PVP, and now we've got something really interesting. We've got, for the 64, where's my cursor? There it is. For the 64 octets, very consistent 4.5% of offered load. For binary search with loss verification, some more variation, but also much higher values. And fairly, I mean, this is fairly consistent, although you're seeing some jumping around here, and quite a bit higher percentage of offered load for the binary search with loss verification. Fairly consistent there too. And notice now the reversals are happening. They're working in each one of these cases. So the loss verification is doing some work to try to characterize the resource exhaustion. All right, so let's press this. So we went about investigating this. So I plotted here the number of losses for each of the binary search trials that were at 6.25% of max offered load. Remember, I showed that as a special case before. All of them had packet loss counts on the order of 700. When we ran loss verification, sometimes we saw that too, but other times 0. Loss verification, again, this was the first trial, it saw 0. Another one here, loss verification at 644, and then loss verification repetition, it seems to have seen now two of these transients that are roughly accounting for about 700 packets. So this, if we go back one slide here, let's see. Just making sure that this is the, yeah, this is PVP, right.
Are
So
you going to
that's
be able
this
to
one.
tell us where the transients came from at the end of this presentation now?
I wish we could. We're
Oh.
still searching for that. That's what Sridhar Rao is at home doing right now. So, but we're gonna track that down. And this is the trial where we saw loss twice during loss verification. It's a really low value. So we've obviously got some improvement to make here in terms of trial duration because we're not really avoiding the transients. All right. So we looked at this in 15-second trial duration. And now look what happens. Binary search saw this nominally 700 frame transient about half the time. And look at the effect on throughput. When you saw it, it's 4.5%. When we didn't see it, it's 9.1, and so on and so forth. And interestingly, almost all of the loss verification cases didn't see it. There were some cases where actually where we saw 0 loss at 12.5% of offered load. And the one case where we did see it, look, it's still the same sort of standard value, kind of, I mean, there's obviously something that we need to track down here. So then we looked at 128 octet frames. Maybe this frame count, this lost frame count, is somehow related to the frames per second. Well, it turns out it looks like it's not. I mean, these are actually a little bit higher, but they're all in the 700 frame loss count range. And we're seeing the same kind of thing with the 30 seconds. All the binary search was bothered by it. Loss verification once, but the repetition took it away. And if we go on to 15 seconds, now we're really seeing some payoff here. We only saw this transient once at the 128 octet frame per second. So I've got some graphs here that show kind of how graphically how the binary search works. One of the things we saw was that when we tested twice at 100% of maximum offered load, we were kind of wasting our time. Because as I said, we were seeing like 50 million frames lost. So we put a threshold in to reduce the number of repeated trials when we see loss over a certain threshold. There's no reason to set this like really aggressively. But it makes sense not to repeat some of these where the loss ratio is really high. So so this graph shows kind of in orange we've got the lost frame counts, and we're seeing those. Let's see here. This is for a PVP setup, 128 octets, and this is binary search with loss verification. So we're seeing some losses in the kind of in the onesie twosie range here, and some are greater than 2,000. They're not plotted; they're above the range. So we may have more phenomenon in this PVP case that we need to account for here. It's not the same kind of thing we saw at 6.25% of loss. Those would actually, in this particular case, we don't even get down that far. So roughly 12.5% would have been about the equivalent. Okay. Another similar thing. I'll just skip over that. So let's see here. Oh, and this is 30-second trial for PVVP. This is where we've got 2 VMs in the case. And I mean, we're seeing about the same consistency here for binary search with loss verification. Really bad consistency for binary search alone. It's almost doubling here in some cases. So, you know, and obviously, again, binary search with loss verification is doing some work. We're seeing some reversals. So then we did this 15-second trials, and we did 4 trials at 64 octets. And for binary search, we kind of reversed the rows here a little bit, so watch out. We've got the same kind of banging across the range here, almost a doubling in the results. The standard deviation of those percentages is 2.41, and the received frames per second that we're seeing is, you know, almost 1 million frames per second. With loss verification and loss verification V2, where we added the loss threshold, now we're seeing much better consistency. And we've got that for the 15-second trials in 128 octets too. Roughly the same kinds of improvement here. About a factor of 2, roughly, something like that. So we're seeing improvement, but have we solved the whole problem? No, probably not. I don't have the energy to go through this, but I looked at the histograms of loss frames for each of the cases we examined. And so we're seeing kind of the difference between 30-second trials at 64 octets and 15-second trials at 64 octets. And what we see is that some of the instances of counts in the, you know, like we expect a lot here near 700, right? We saw a lot of those at 6.25. Those all went away. They're kind of gone now. They've got distributed, you know, maybe down in here or maybe even lower. So there may be more than one transient causing those 700 nominally 700 counts. And unfortunately, there was more trials at the 15-second case, so you can't really look at the exact numbers, but the big ranges kind of show the difference. Same thing here for which one is this? Oh, this is PVVP, so 2 VMs, and you know, it's shifting again. So we've got more to understand about these things. So our next steps, as Sarah asked already, but you know, we still need to identify the processes that cause the loss. We need a better measurement tool that can help us characterize the bursts and run in this long-term mode. I'd like to add a heartbeat check to our test VM where it just loops back the packets. I think that would be valuable because that way we can tell when that VM itself has been interrupted. And observe the logical interface drops on the sort of the northbound side of the OVS. I think that would be helpful too. Any questions or comments?
Have you guys figured out how you're going to timestamp the loss events yet?
No, we need like a really inexpensive open source tool that will help us do that.
Are you working on this project yourself, Al, or are you just presenting the output?
I'm working on the project myself, yes.
Oof, I might be able to connect you with somebody from our side who works in OPNV as well, who might be able to help you with that timestamping.
Okay, good.
Kick me after, remind me after.
Yes. I will not kick you. I will remind you. All right. Anything else? Good. Thanks for that recommendation. I hope this was informative. And now we've got Paul. Some more interesting stuff. All right. I think this is it. Let's put this back. Let's do it this way. Paul, here's the clicker. We're going to look at it. Okay.
Okay, thank you. Well, I'm a researcher, and this is joint work with my colleagues Sebastian, our student Alex, and our professor Georg, and we are looking at packet generators, in particular researching packet generators and whether they are reliable to, oops, that's the wrong mode. Could you, this is scrolling the wrong way.
Oh, it was like it's scrolling it. That's kind of weird.
Just click the full screen.
Well, he might not have presented. Is it a PDF?
Yeah, it is.
That's why.
No, it's
No, can you
it's
click
been
the-
working- it's been working fine. Hang on a second. Let me, did I press, oh, you know what I did? I didn't press this button. There we go.
Okay, let's start this again. So packet generators. They are expensive packet generators. They are, of course, awesome and work perfectly. Then there are cheap packet generators on network cards like these Intel cards. Are they awesome? We don't know. Maybe they are, but that's something we are looking into. So the first question is, of course, what are the metrics that you're looking at? What do you want of your packet generator? What do you expect your packet generator to do? Like, that would be functional features or reliability features. Then can a cheap packet generator be reliable, and how to measure it? And how would you validate a packet generator, whether it works as advertised? If you look at the packet, if you have a new packet generator, can you test the packet generator to see if it works as specified? And then, is that precise and is it accurate? And one thing you already noticed, I'm asking a lot of questions. I don't have a lot of answers. I just have a lot of questions to maybe get something started about how to answer these questions, maybe, hopefully. Yeah, so let's start with the first question. What should your packet generator do? Here, I just looked at the ETC specification that was previously mentioned a few times here, and it has actually a section on requirements for the packet generator to be used for the benchmarking there. And I paraphrased the section here. These are the main requirement. It says it has to accurately generate constant frame at specified rates. So you have to configure some rate and then send packets. Okay, seems like a very reasonable requirement. Then it also wants you to generate bursty traffic at a specified rate, with specified burst length. Okay, nice. There are also some more requirements I haven't listed here, like multiple flows and so on. And then the third main requirement is it is supposed to do accurate latency measurement, and the timestamp is applied, this is direct quote, as close as possible to actual transmission. Whatever that means, if as close as possible is somewhere a millisecond away and they just can't move it closer, then it would be okay for that specification, because it was as close as was possible with that packet generator. It just wasn't a good packet generator. And one thing I want to talk about is, since the specification here only mentioned accuracy and never precision, I just wanted a short picture about these two terms that are often intermixed and so on. Accuracy versus precision on the example of latency measurements, but can be applied to other metrics as well, is two different things. For example, we have a packet generator here, and we just connect two ports of the packet generator with a cable, like we are measuring the cable. The ideal packet generator would, well, the cable, of course, doesn't lose any packets and so on, but if you measure the latency of the cable, it should be the same value every time, or at least as close as possible to the same value. So the precision here would be that the deviation between individual measurements of timestamps is low, meaning each each time of flight of the packet is measured as X nanoseconds. And the typical source of a measurement error in the packet generator here is that it includes a queuing delay on the generator or receiving side, that the timestamp is taken in software before it's transmitted to the card of the packet generator. Then the second thing is you can look at accuracy is that it reports the correct latency, as in, the correct latency would only depend on the length of the cable. The typical source here is that some processing time is included and there's some static overhead. The big question here is, what is the ground truth? What is the correct latency of a cable? You can estimate that. And we've done this measurement with our Moongen packet generator. We have done it actually with a few different cable lengths here. We have just attached a 30-meter cable to the packet generator, and we send packets to it. And the idea is the cable should always report the exact same latency. And on this graph, you can see at the x-axis is applied load to the cable. So we apply an increasing load to the cable with 64-byte packets. And the y-axis is the measured latency, and it's a box plot, meaning the big boxes are the 10s to 90s percentile. The marked thing in the middle is the median, and the outlier dots are the minimum and maximum reported latency of the packet generators. So what we can derive from that here quite easily is the precision of the timestamping of the packet generator. So that would be around 37 nanoseconds. There's just the deviation between the minimum and the difference between the lowest reported latency of the cable and the maximum reported latency of the cable. 37 nanoseconds, that's quite good, I think. It's better than you usually need. And the accuracy is more tricky to measure, because what is the ground truth? How fast should a cable be? And this we can estimate. We can say, okay, the propagation speed and that was a single mode fiber optical cable should be around 2/3 the speed of light. We can estimate it should take 150 nanoseconds for a packet to pass through that. And the average reported latency here is 161 nanoseconds. So it's kind of close, but we can't really quantify how good it is, because we can only say it should be low, but how low should it be? One thing that could be done is like use different cable lengths and see if the difference between cable lengths is somewhat reasonable, and so on. But it's a tricky thing, and I don't have an answer to this. Maybe one can use a very short cable and say, okay, this should be basically no latency. Does it report basically 0, or does it report some absurdly high value? This is also something where a lot of packet generators will already fail. We have also done this test with software timestamping that we have implemented as good as we could. We took all the precautions, and in this test, this fails completely. There are microseconds of latency of the cable, and there are sudden peaks when the latency increases, and so on. Then there's two things I basically want to talk about. The first one was this latency measurement. How can that be measured? And the second thing is traffic patterns, or not only traffic patterns, also the speed that packets are sent out. The main thing, the main traffic pattern that you see is the typical constant bitrate traffic pattern that is defined as same space between all the packets, meaning you want to send 1,000 packets per second. You configure a packet generator to do that, and then you tell it to do CBR, and then you expect it to insert a space of 1 millisecond between each packet. Then there, of course, bursty traffic. Bursty, some packets are sent with no gap between them, and then a larger gap, more packets. And quite nice one is the Poisson distribution, where there's an exponential distribution of the gap of the packets. Then what is usually used? Well, CBR. RFC 2544 just says by default use CBR, but you can also do more tests with other traffic patterns if you want to. I don't think anyone does that, but yeah. Then the ETSI NFV TST9, they want explicitly CBR and bursty traffic, which is, well, fine, because bursty traffic is really easy to generate. If you tell your software package generator you want some traffic, it will give you bursty traffic by default, because it's easier to implement bursty traffic, because that's just how all the APIs and all the hardware is optimized. It's optimized to work in a burst of traffic. The problem is sometimes they will give you even bursty traffic if you explicitly ask for constant bitrate traffic, which is bad for your results. Then CBR is actually, it sounds like the easiest pattern, because just use the same gap every time. Sounds easy, but it's actually the hardest to implement and the most annoying to implement. And in particular, it's annoying to scale to multiple cores, because then one core would have to know when the last one was sent without hardware support. That's really annoying. Poisson traffic has a few nice properties. For example, if you take Poisson traffic from two different links and just mix them via switch or on the network card with multi-queue, or just somehow multiprocessing, mix stuff together, adding to Poisson distribution yields a new Poisson distribution, so you can easily scale this up. And Poisson is arguably the most realistic traffic pattern for real-world traffic. It's not quite how real-world traffic looks like, but it is way closer than CBR traffic, and bursty traffic is also all right for some situations. But let's look at whether that actually matters, because it sounds like such a distinction, like who cares how the packets are really spaced on the wire, just packets and it's fine. So this is just an example measurement. Setup, really simple. One host sending packets, one host running Open vSwitch, no fancy Open vSwitch, just the standard Open vSwitch in the kernel, no fancy optimizations, and we apply an increasing load to ports where it forwards packets with just a static OpenFlow rule, no magic there. We are using the Intel IXGBE driver, which has some dynamic interrupt throttling, and we have the kernel poll mode NAPI. And yeah, what you can see in this graph is we apply an increasing load measured in million packets per second on the x-axis and measure the latency of the traffic in microseconds on the y-axis. So what happens here is everything seems kind of fine. Packet rate increases, latency also increases, but then suddenly something weird happens down here. Turns out that it switches into a different mode. It goes into polling mode, and it's complicated. We have a whole paper about it. I don't want to go into that, but basically just an example of what a measurement could look like. And what we can now do is we can repeat the same measurement. And the only thing we change is we change the traffic pattern, meaning now we don't use a constant gap between the packets, but we just use a random number generator, use a nice exponential distribution, and it results in the same average packet rate. We send the same amount of traffic over the same time. It's just sometimes they are closer together, sometimes they are farther apart. And now we get a much more realistic and nicer response. Yeah, and the point is we get a completely different response from the device under test just by changing one parameter at the packet generator. And it's a parameter that is often ignored by packet generators, not supported well, and that can be a problem if you're looking at latency measurements. We found it to be not a big deal for throughput measurements, but for latency measurement, it's kind of a big deal. So I have more questions here. These two things I've mainly talked about is, say, for example, if we wanted to specify how to benchmark a packet generator, it would be probably define several tests that would start with, say, this packet generator supports latency measurement, so let's measure how good is the latency measurement by measuring the latency of different cables of different lengths of a specified cable type and report what is the latency that the packet generator reported. And then this test needs to be repeated while applying different types of traffic to the cable, because thus changing anything in the packet generator affect how well it performs. Especially increasing the load can affect your latency measurement if it's not done properly, because queues might fill up. And the open question is, what is the ground truth for the latency of the cable? Can you just use a shortest cable you can find and say it should be around 0? Second thing are these traffic pattern. That's really hard to measure, to quantify what is really going on. We did that once 2 years ago, and it was really annoying to do because it's really hard to measure on commodity hardware. You receive a lot of packets, and it's really hard to take a timestamp of each packet on just your normal commodity hardware with the necessary precision. We have done it using an FPGA, and that did work. It was a quite annoying setup, and realistically speaking, yeah, it's not that easily repeatable because most people don't have FPGAs lying around in their servers. Yeah, and there are two things since I just heard about the packet generators apparently fail to even generate the packet rate that was specified. Then that should also be tested, but I just assumed that would get the basic stuff right. And then, well, I actually knew better than they get the basic stuff right, but I thought it got better over the last year. Oh well. Then the last open question I had here is the traffic pattern. I had this graph comparing CBR and Poisson traffic, and often CBR is required or wanted. Is it really a good idea to have CBR traffic as a default because it's not the realistic thing that your device will encounter in the real world? So the benchmark should somehow model the real world. Yeah, I'm also going to show one more backup slide that I had here. This is an example that we did with the FPGA setup that I mentioned. We had a few packet generators here, and this is a histogram where we configured each of the packet generators to send constant bitrate traffic. And the histogram, the buckets are the actual interpacket gap, and the line in the middle is 1 million is 1 microsecond. So the target was hitting exactly that line. So the ideal result would have been 1 histogram bucket at the exact middle. And the very left is a back-to-back frame, and the right is, I think, double that was what was configured. So usually it results in something that is certainly not completely a CBR, but it's usually quite close. Except some packet generators that just like to ignore the configuration and some things. This is when you increase the packet rate here. We increased it to 4 million packets per second, and then one of them just decided it will send bursty traffic anyways because that's easier, and the other ones are not that close. And for Moonshine, the results are with software rate limiting. We have other rate limiting methods that actually hit that quite precisely like that. That's what it should look like. And this is what it usually looks like. So good, bad. And this is something that could be reported for a packet generator, but it's hard to measure, so not sure if it's a good idea. And there were some questions, so does someone else have questions or maybe even answers?
You're saying CBR is bad. You seem to
Yes.
be saying Poisson is good.
Yes.
Are you saying you plan to come back and issue an update to 2544 to remove the recommendation for CBR?
Sure, why not?
Okay, what are your next steps then?
No idea, you tell me.
Okay.
Well, there's it seems to me that one of your tests, which is very simple but also very informative, is something that appeared in the kind of in the IPPM framework a long time ago. The idea of testing the measurement system with this simple cross-connect cable, and it seems to me that we could make a series of recommendations like that for people putting together their test setup and turning, instead of a lot of hand waving, and I don't really know what happened here, into science. If we give them a few prerequisites to, especially associated with their traffic generator. I think that there's probably space and a welcome audience for a draft like that in this working group.
And Warren Kamari, this is probably kind of a tangent, but I'm just interested. For the 30-meter cable, you had 0.66C. Did you get that just sort of from a lookup table, or did you actually look on the cable? Because you can get cables which are actually, where they report what their propagation speed is.
That was just a wild guess.
Just a wild guess. Okay, cool.
So that could be a consideration in the calibration too, that you spend
Yeah.
a little extra and get your cable calibrated.
The other obvious thing is the SFPs with serializing and deserializing delay.
Yeah.
There is actually, I can't remember who, one of the vendors specifies
in-
that, which is,
Yeah, in this specific measurement was actually a more complicated setup where we had fiber taps before and after the cable and had the packet generator and the latency measurement separate, and like the packet generator inserted sequence numbers, and then we had two tap ports on a fiber tap going to a packet collector and taking the timestamps there. So assuming that both the transceivers on the receiver have about the same, then it would cancel out. And there's actually, if you measure that without the fancy setup, then you get a latency of around 400 nanoseconds.
I think this is good stuff. I think we tried to go down a little bit of this path when we did the data center benchmarking, but we included it mainly just around, okay, you got to use, if you're going to use a cable to test multiple systems, use the same cable, right? Basically, or just use the same set of transceivers so you can kind of like at least take out that drift. And then I think another thing that I didn't mention is that also if you test different, especially from the two different systems, they're going to have two different clocks. So they're going to be, Ethernet has like 100 parts per million drift.
Yeah,
you can kind of play with as well.
We don't use different systems. It's just asking for trouble.
Yeah, but it's still something to take a look at too. But.
Yeah.
Well, thanks very much, Paul, for bringing this informational test results to us, and for making some recommendations about how we can do this work better. I hope you can imagine some time in your future to follow up with some of these things and maybe work in this calibration recommendations area. I think you'd have some welcome reviewers here and maybe even some welcome co-authors. To get
Yeah.
this done. Cool. Good. Very good.
Thank you.
Well, thank you. Thanks everybody for playing along, especially for a few extra minutes here this afternoon. Has everybody signed the blue sheets? Everybody?
So,
Okay, because we need to get every name on there so we don't get assigned a tiny little room next time. That's the defensive participation we're looking for. So, anything else?
nope, take it to the
Okay, please, everybody, read all the drafts. That's how we get good work done here. We really appreciate you doing that. Thanks for joining us, folks who joined us for the first time, and we'll see you on the list.
Thank you.
Yeah. Yeah, I think I'll delete all these windows so that the next person doesn't have to do it. Yeah, this is where somebody left it for me, so they can certainly scroll.